Machine alignment is a critical but often overlooked aspect of machinery maintenance. Proper alignment ensures that rotating shafts are parallel and concentric, minimizing vibration, wear, and energy waste. Think of it like this: when the wheels of your car are properly aligned, it drives smoothly and efficiently. Misaligned wheels lead to uneven tire wear, poor fuel economy, and a bumpy ride. The same principle applies to industrial machinery, where misalignment can result in costly downtime, premature component failure, and even catastrophic accidents. By taking the time to properly align machinery, we can significantly extend the life of our equipment, reduce maintenance costs, and improve overall plant efficiency. A well-aligned machine runs smoother, quieter, and consumes less energy. Moreover, proper alignment contributes to a safer working environment by minimizing the risk of vibration-related accidents. In the following sections, we will delve into a step-by-step guide to mastering machine alignment, covering everything from pre-alignment preparations to final checks and documentation. While the process may seem daunting at first, it is well within the grasp of any maintenance professional willing to invest the time and effort. By following the steps outlined in this guide, you can ensure that your machinery operates at peak performance and reliability. Remember, a stitch in time saves 9, and nowhere is this truer than in the realm of machine alignment. Before we even begin the alignment process, it is crucial to lay the groundwork for a safe and successful outcome. This involves several essential steps, starting with proper lockout-tagout procedures. Always de-energize and isolate the machinery from the power source before commencing any work. This eliminates the risk of unexpected startup, safeguarding both personnel and equipment. Once the machinery is secured, thoroughly clean the work area, removing any debris, oil or grease that could interfere with the alignment process or pose a safety hazard. Inspect the machine for any visible damage, such as cracks, loose bolts, or excessive wear. Address these issues before proceeding with the alignment. Finally, relieve any pipe strain that could be affecting the machine's position. Pipe strain can exert significant forces on machinery, leading to misalignment and premature wear. By meticulously addressing these pre-alignment tasks, we create a safe and controlled environment for the alignment process. This sets the stage for accurate measurements and optimal results, ultimately contributing to the longevity and reliability of our machinery. Remember, a well-prepared alignment is half the battle won. With the pre-alignment checks complete, we can now move on to the rough alignment stage. This involves bringing the driver and driven machines into approximate alignment using visual methods and basic tools. Begin by loosening the mounting bolts of both machines, allowing for positional adjustments. Using a straight edge and feeler gauges, visually align the shafts as closely as possible. The goal is to achieve parallelism in both the vertical and horizontal planes. Fill any gaps between the machine feet and the base plate with shims of appropriate thickness. Shims ensure even weight distribution and prevent the machine from rocking or vibrating during operation. Once the rough alignment is complete, gradually tighten the mounting bolts, ensuring that the alignment is maintained. Avoid over-tightening the bolts, as this can distort the machine frames and introduce errors into the alignment. Remember, the purpose of rough alignment is to establish a solid starting point for the more precise alignment procedures that follow. In this section, we'll conduct the first alignment check and correct any soft foot issues to eliminate hidden errors. Soft foot occurs when one or more of the machine feet do not sit flat on the base plate, causing distortion in the machine frame when the bolts are tightened. To check for soft foot, use a dial indicator to measure deflection as each bolt is loosened and tightened. If soft foot is detected, use shims to fill the gap and ensure all feet are firmly in contact with the base plate. Properly addressing soft foot is crucial for achieving accurate alignment and preventing future issues. With the soft foot corrected, we can proceed to fine-tune the alignment for optimal performance.